Parallel, perpendicular. All right, tell me about number 1. Who can tell me? Yep. Why is it neither? So the slope here is 1/3 and the slope here is 3. Why are they neither? Yep, so you've got reciprocals, but you do not have opposite reciprocals. So this answer would be neither. So I'd like you to take a few minutes and try 2 through 5, and then we'll talk about the answers in a minute. So what did you end up saying? -5/7, -7/5. Yep. Neither again, because one of them needed to be positive, right? We've got reciprocals, but we don't have opposite reciprocals. What did you say for number 3? Parallel. They're both a slope of 2/3. So that would be parallel. And what did you say about number 4? They're both a slope of 2, right? So parallel again. So we didn't have a perpendicular set, so don't go looking for one when there isn't one. All right, and then the little application about parallel lines. Admission to a fair is $5. The cost to ride each ride is $1.50. Julie received a half-off coupon that applies to the admission price. She decides to graph the total cost on the y-axis and the number of rides on the x-axis. So her total cost was $1.50 per ride plus the $5 admission. And the other one was $1.50 per ride plus her $250 admission to represent the discounted cost. Which best describes the appearance of the discounted line to the regular cost? Less steep, more steep, same steepness, discounted cost closer to the origin, or same steepness, discounted cost further from the origin? What would you say? Why would she already know that? Because she's smart? I know, that's true. But at least you could have. It's good point. Yep. Anyone going to the Freiburg Fair in a couple weeks? Anyone go on bracelet day so that you don't have to pay per ride, but you can have unlimited rides with a $20 bracelet? You what? No one does the bracelets. We should calculate that cost. How many rides do you have to ride to make the bracelet worth it, right? All right, skip ahead to 212. So the top 2 problems, I'm going to have you go and try on your own. You got to put them in slope-intercept form and find the intersection point graphically. But then you've got these 3 problems at the bottom that are all based on substitution before we look at some application problems today. So let's do one of them together, and then you try the other 2, and then go back up to do the graphing. So take a look at number 3. Do I have one of the variables by itself? This is guided practice 212. Do I have one of the variables by itself on number 3? Just go for the first one, right? So this y is by itself, right? What do I do with this rectangle part? Where do I put that x minus 1? I'm on 212, the guided practice. We already did the notes on 212, so I skipped ahead the substitution practice. So where the other y is, right? So the circles need to be the same. So I'm going to put the rectangle in where that y is in the second equation, right? So I'm going to rewrite the second equation as a new equation, right? This is the hardest part, rewriting the second equation correctly. We're on 212 guided practice. So x equals 1 minus, and then in parentheses, I'm going to substitute in that x minus 1. So I have this y by itself. So this rectangle part is going where this y is in the second equation. Now I've got this equation right here. Now I have to do the distributive property and solve for x. For distributive property, I'm just distributing a negative sign. So I would have x equals 1 minus x, and then a minus minus would make it a plus 1, wouldn't it? All right, what's my next step? Trying to get x to one side of the equation? Add like terms. So what did you mean by that? Okay, so I really have x equals 2 minus x then, right? Because 1 plus 1 is 2. Yes, I'm going to add what to the other side? X. So yeah, whether you combine like terms on this step or you add x at this step, those are kind of, they could go in either order, right? So now I have what? These x's are gone. I now have 2 x's on the other side of the equation equal to 2. If 2x is equal to 2, what is x equal to? So x equals 1. So I just found half of my solution, right? Because our solution is the intersection point of the two lines. Now what do I do? If x is 1, how do I figure out what y has to be? Put it into the equation, and the best place to put it is right back into this rectangle equation up here, because I've got y equals, so when I plug in 1, what do I get? 1 minus 1 is 0. Y has to equal 0 then, right? I plug 1 back into the rectangle. 1 minus 1 is 0, so y equals 0. So my final solution is 1, 0. Kind of hard to see in all that work, but my final answer is written like this, 1, 0. And be on the lookout in example 4 and example 5, because I'm not sure the outcomes of those. I don't remember them. But we had two kind of strange outcomes on Friday. All of our variables canceled out, and we got a false statement like 7 equals 10. That tells us there's no solution. The lines were parallel. All of our variables canceled out on this one. We got a true statement, negative 200 equals negative 200, and we said many solutions because it was the same line on top of itself. So I'm not sure if you're going to see that on either of these problems, but just be on the lookout for that when you're doing algebraic manipulation. All right, so you're going to try 1 and 2. You got to put them in slope-intercept form and graph them. Find the intersection point. And then 4 and 5. And then we should be kind of warmed up and ready to try something new. I'll put, for the sake of the video, let's see, did you divide by 2 on this first equation? So you got y equals 2x minus 3, right? 2x minus 3. So I start at negative 3 up to over 1. So there's my first line. Right, a system of equations is more than one equation, right? So my second equation, I have to divide through by 4, and lo and behold, I get the exact same equation written twice, right? So the solution is, that's graphed on top of the self right here. So the solution is many solutions, or infinitely many solutions, because every single speck on this purple line is on the other line, right? So where do they intersect? Well, it's the same line. So they intersect everywhere on the line. All right, so make sure you write this conclusion, right? Because just graphing the line, that was so last week. This week, we're looking for the intersection point. So we need to write that as our final answer. So let's see, the next one is y equals 1/2 x plus 4. So that's in graphing form. Up 1 over 2, down 1 over 2. There's, remember, rising, it should go up to the right. So it's a positive slope. Let's see, this one, when I divide through, I get y equals 1/2 x minus 3. So what happens this time? They are what kind of lines to each other? Parallel lines, which means my final conclusion is what? Right, they never intersect. So I have to write down my conclusion that there is no solution to that system. Did we get those 2 for 2, hopefully? So those are pretty reasonable to convert to slope-intercept form, right? No, not too crazy for algebra. All right, so down here, you're looking to get a variable by itself. All right, I've got a variable by itself. My y in this equation is equal to 4x plus 1. So that means that the y in the second equation can also be equal to 4x plus 1. So I rewrite it as 2x plus 4x plus 1 equals 37. So see how I've replaced the y in the second equation with 4x plus 1. Did you get that far? So now tell me what I do next to solve for x. Yep. Well, so I get 6x plus 1 equals 37. So what's my next step to combine like terms? Subtract the 1. So I get 6x equals 36. So x is 6. Divide by 6 on both sides, and x is 6. That's half of my answer. So there's a lot of algebra that we need to practice. So once I get that x is 6, where's my easiest place to plug it back into? I like that rectangle up there, right? Because that's a y equals equation. So if I plug 6 back in, what do I get? 4 times 6 is 24, plus 1 is 25. So 6, 25 is my solution. So let's set up the last one in case you haven't had a chance to try it yet, and then maybe you can do, once we get our equation, solve for x and y if you're still having trouble. All right, I don't have anything by itself yet. So I have to pick one of the variables. What variable should I get by itself? What do you want to throw out there? The y. This y? This y? So what are you going to do? Subtract the 3x and then divide everything by a negative? All right, we'll go with Devin. I would have just subtracted one of these. Let's just do that. Can we solve for like this x maybe? How about that? Let's subtract y to the other side. So x equals 9 minus y. Bam, one step, I got it by itself. So where am I going to put it? I'm going to put it in for x in the top equation, right? 3x. So where that x is, I'm going to rewrite it as 9 minus y. And then you're going to solve it the rest of the way. 3 times 9 minus y equals negative 5. So can you take it from that step, distribute the 3, and maybe solve for y? I think you can. My faith is in you. I'll put up the next two steps. 27 minus 3y minus y becomes 27 minus 4y equals negative 5. Are you on the right track so far, solving for y? So see if you can take it another couple steps and get y by itself. All right, so I subtract 27, is that right? Yep. Negative 4y equals negative 32. So when you divide by negative 4, y is 8. And that's only half my answer, but it's really easy to get my other part of the answer with this rectangle over here, right? I just substitute in my 8, and that basically tells me exactly what x is going to be, right? 9 minus 8, so x is 1. So 1, 8 is my final solution of my intersection point of those lines. So that is a lot of work, right?